Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic Elimination Reactions. For links to other topics and question timestamps, please visit video description. Question 27. 1,2-dibromopropane can be made from 1-bromopropane in 2 steps. Which row is correct? This is 1-bromopropane, CH2, CH2, CH3. We have bromine atom on first carbon atom. Now first this compound can be reacted with sodium hydroxide ethanolic. Elimination will occur and HBr is removed from this compound, so we will have CH2 double bond CH CH3 plus NaBr plus H2O. Now in order to make this alkene into 1,2-dibromopropane, we can add aqueous bromine. So the product would be CH2 Br CH Br CH3. Now the first step was elimination and second step is addition. So therefore answer is B. Question number 26. Structural isomerism and stereoisomerism should be considered when answering this question. 3-methylhexane-3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula C7H14. How many isomeric compounds could be formed in this reaction? In the reactants we have 3-methylhexane-3-ol, as this ends in ol, so therefore it is an alcohol. And now we know that what happens when hot concentrated sulfuric acid is reacted with alcohol, actually water molecules is removed. So this is a dehydration reaction. Now we can see that OH is present with this carbon atom and hydrogen will be removed from adjacent carbon, which could be this one or this one or this one, as all three are adjacent to this OH carbon. So when hydrogen atom from adjacent carbon is removed and OH from this carbon is removed, it will form an alkene. So 3 different alkenes can be formed. Now first possible product could be this one. Now in this product we can see that this carbon atom is attached with 2 hydrogen atoms, and as both atoms are similar, so therefore no cis trans is possible, only this product is formed. As both hydrogen atom attached with a double bonded carbon is same, so therefore cis trans isomer is not possible. In the second product, the double bond could be present between these 2 carbon atoms. If hydrogen atom is removed from this one and OH is removed from this carbon. Now we can see that with double bonded carbon atoms, 2 different groups are attached with this carbon, and again 1 hydrogen atom and 1 CH3 is attached with this carbon, so therefore cis trans isomerism is possible. So one product will be cis and second will be trans. For the third product, the double bond will come between these 2 carbon atoms. So again we can draw the structure. You can see that the double bonded carbon is bonded with 2 different groups, and this double bonded carbon is attached with 1 hydrogen atom and 1 is this group. So again cis trans is possible. No other product is possible, so therefore we have 1, 2, 3, 4, 5 possible isomers formed. The answer is therefore C. Question 25. Which product can be made from bromoethane by elimination reaction? Let's first draw the structure of bromoethane. We have two carbon atoms. On one carbon we have bromine atoms and rest are hydrogen atoms. Now elimination means the removal of a molecule. In this case, bromine is removed from one carbon atom and hydrogen is removed from adjacent carbon atom, and double bond is formed instead of single bond. So the product will be carbon-carbon double bond along with the removal of HBr. So we can see an alkene is formed from bromoethane, and this alkene is 2-carbon alkene, so it is ethene. So the correct option is B. Question number 20. Question 25. Dibromopentanes can undergo double elimination reactions to produce hydrocarbons. Which isomer produces only one hydrocarbon product? Double elimination means elimination that occurs two times. As we can see in this structure, we had 10 hydrogen atoms, 2 bromine atoms. Now in this structure we only have 8 hydrogens, so 2 hydrogen atoms are lost and 2 bromine atoms are lost. In single elimination, 1 hydrogen and 1 Br is removed. Hydrogen forms water and Br will form sodium bromide. In double elimination, 2 hydrogen atoms and 2 bromine atoms will be removed to form 2 sodium bromide and 2 water molecules. Let's do double elimination in these structures. First one is 1,5-dibromopentane. In pentane we have 5 carbon atoms in the long chain. On first and fifth carbon we have 2 bromine atoms, so this is 1 bromine, and on fifth carbon this is second bromine. Now bromine is eliminated along with the adjacent hydrogen atom present on adjacent carbon. Similarly, this bromine will be removed along with this hydrogen atom. In the presence of sodium hydroxide, sodium will form NaBr along with these 2 Br, so it will be 2 sodium bromide, and these 2 hydrogen will be removed to form 2 water molecules. Whenever elimination takes place, single bond is converted into double bond, as these 2 carbon atoms are involved in elimination and these 2, so therefore one double bond will come between these 2 carbon atoms and one double bond between these 2. So the product will be C double bond C, then we have single bonds, then again double bond C. Rest are the hydrogen atoms. The molecular formula is C5H8. This is the only hydrocarbon product that is formed, so therefore A could be correct option. In B we have 1,4-dibromopentane. Again we can draw pentane having 5 carbon atoms in the long chain. On first carbon and fourth carbon atom we have bromine. From adjacent carbon hydrogen will be removed and elimination will take place. Now from this carbon bromine is removed and from this carbon hydrogen will be removed, so there will be a double bond between these 2 carbon atoms. While this carbon has 2 adjacent carbon atoms having hydrogen, so either it could be eliminated from this carbon or hydrogen could be eliminated from this carbon atom. So double bond can either come between these 2 carbons or between these 2. Let's draw the product. We have sodium hydroxide. Now there are 2 possible products. In first one this double bond is present. Then we have 3 carbon atoms. Now if this hydrogen is removed along with this Br, then double bond will come between these 2 and this will be the product. If this hydrogen atom is removed along with this Br, then the product will be like this. Rest are the hydrogen atoms. In first hydrocarbon product we have double bond on first and third carbon atom, while in second hydrocarbon product the double bond is on first and fourth carbon. Other product is NaBr and H2O. Now as we can see that two hydrocarbon products are formed, so therefore B is incorrect. Let's look into the third one. We have 2,3-dibromopentane. In pentane we have 5 carbon atoms. On second and third carbon we have 2 bromine atoms, so this is second carbon and this is third carbon. Now elimination can take place in such a way that this hydrogen is removed along with this bromine. So second elimination will be possible if this hydrogen atom is removed along with this bromine atom. We can also see that this carbon has hydrogen atom present, so this bromine can also be eliminated with this hydrogen. So the second double bond can either be between these two carbon atoms or between these two carbon atoms. The possible products will be like this. We have double bond between first two carbon atoms, and then if this hydrogen is removed along with this Br, then double bond is present between these two. And if this hydrogen is removed along with this Br, then we have this structure as product. Rest are the hydrogen atoms. As we can see that the double bond is present on first and second carbon, and in this structure double bond is present on first and third carbon, so therefore both hydrocarbons are different. So as two hydrocarbon products are formed, C is also wrong. Last one is 2,4-dibromopentane. Again we have 5 carbon atoms. On second carbon and fourth carbon we have bromine. Again elimination can take place in such a way that one hydrogen atom is removed from adjacent carbon. Second double bond can either come between these two carbon atoms if this hydrogen is removed along with Br, or between these two carbon atoms if this hydrogen is removed along with this Br. The possible products will be like this. In first product we have double bond between first two carbon atoms as these two are removed, and another double bond between these two carbon atoms as this is removed along with this bromine. Now in second possible product, first double bond will be at the same place, while second double bond will be between these two carbon atoms as this hydrogen is removed along with this Br. Rest are the hydrogen atoms. In the first product, double bond is between first two carbon and then third and fourth. In second product, double bond is between first two carbon and fourth and fifth. Two hydrocarbon products are formed. This is also incorrect. Only correct option is A. Question 27. A reaction occurs when a sample of 1-chloropropane is heated under a flux with sodium hydroxide dissolved in ethanol. Which row is correct? 1-chloropropane means we have 3 carbon atoms and chlorine is present on first carbon. Upon reaction with sodium hydroxide in ethanol, elimination takes place. In this elimination process, one halogen and one hydrogen from adjacent carbon is removed and single bond is converted into double bond. So alkene will be produced. Along with the removal of HCl. So the type of reaction is elimination and name of product is propene, as it is an alkene. Answer is therefore B. Question 24. Structural isomerism and stereoisomerism should be considered when answering this question. A colorless liquid C5H11Cl exists as a mixture of two optical isomers. When heated with sodium hydroxide in ethanol, a mixture of only two alkenes is formed. What could the colorless liquid be? Now for halogenoalkane, the reaction in sodium hydroxide in ethanol is elimination reaction. In elimination reaction, small molecules are eliminated. In this compound we have Cl, so HCl will be eliminated and alkene will be formed. In the question they have given that a colorless liquid, this halogenoalkane, exists as a mixture of two optical isomers. It means that chiral carbon is present. Let's look into the options. In A we have this compound. Let's draw the structure. We have CH3, CH2, CH, CH3, CH2, and Cl is also present. Now as we can see that with this carbon atom, two similar groups are present. So therefore this is not chiral. So as chiral is not present, so therefore optical isomer will be absent. So A is incorrect. Let's draw the structure of B. We have CH3, CH2, CH2. Then we have carbon having hydrogen and chlorine. Then we have CH3. As we can see that this carbon is bonded with four different groups. So therefore this is chiral carbon. So two optical isomers will be formed. Second process is elimination of HCl. So from one carbon atom, chlorine will be removed, and from adjacent carbon, which could be this one or this one, hydrogen atom will be removed. So the first product formed if hydrogen atom is removed from this carbon would be like this. We have CH3, CH2, CH. Now double bond is formed between these two carbon atoms. So this product is formed. Now in this product we can see that this carbon is making double bond, again this carbon is making double bond, and both carbon atoms making double bond have two different groups attached. One is hydrogen, one is CH3, CH2. On second side we have one hydrogen and one CH3. So therefore this will show cis-trans isomerism. So one product is cis, one product is trans. In second scenario, if the hydrogen atom is removed from this carbon, then the product form will be like this. We have CH3, CH2, CH2. Then we have carbon atom with hydrogen. Now a double bond is formed between these two carbon atoms. Now in this product we can see that this carbon and this carbon are making double bonds. Now with this carbon we can see that both atoms are same, so therefore cis-trans will be absent, only this product is formed. So in total we have 1, 2, 3 products that are formed, and all three are alkenes. As in the question only 2 alkenes were formed, so therefore B is incorrect. Now looking at part C, we have this structure. CH3 is attached with carbon having hydrogen atom. Then CHCl and CH3. Now we can see that this carbon is not chiral as it has two similar CH3 groups. This carbon is chiral as it has 4 different groups. So first option is correct. Now for second option we have elimination reaction. So chlorine will be removed from this carbon and hydrogen can be removed from this carbon atom or from this carbon atom. So 2 possible structures are formed. In first one we have CH3, CH, CH3. Then we have carbon, hydrogen, and if hydrogen is removed from this carbon atom, then double bond will come between these two carbons. Now as double bonded carbon is attached with similar atoms, so only this product is formed, there will be no trans isomer. In second scenario, if hydrogen atom is removed from this carbon atom, then the product form will be like this, CH3. Then we have carbon double bonded with this carbon, and we have CH3. Now as with this double bonded carbon, we can see that similar groups are attached, so therefore cis trans is not possible, only this product is present. So in total we have 2 alkenes that are being formed, so second option is also correct. So C could be the correct answer. Now moving towards part D, we have CH3, CH2, then we have carbon having chlorine, CH3 and CH3. Now with this carbon we can see that 2 similar groups are present, so therefore no chiral carbon is present, so option D is incorrect. Correct answer is therefore C. Thanks for watching. If this was useful, please do like, subscribe and share.